Hey everyone. Well, as the timer says, let's get started. First off, thanks very much for coming. I seem to be the mobile track, the only Android talk today. So thanks for coming to start off with. So this talk is really about trying to sort of harden the security of your Android app, and I go for some practical tips and some things that I've learned over the last couple of years. Just before we get started, can I get a show of hands who's kind of like a Java developer? Brilliant. And keep your hands up if you've experimented with the SDK, the Android SDK. Oh, brilliant. Okay, cool. This talk assumes that you're familiar with the SDK, but I'm not kind of aiming it at security experts, because if you're a security expert, you know that nothing is secure. But yeah, let me just start off with telling you a bit about myself. I'm I was the head of Android at a company called Moobaloo, an apps agency. Today is my last day, bizarrely. But they're a company that do apps for sort of large brands and businesses. I'm really passionate about Android development and security, and I've been sort of in development for about 9 years. I co-run a meetup group for developers in Bristol and Bath and the Southwest. And if you have any questions after the talk, just tweet me. And just while we're kind of on it, just let you sort of know a bit about me. Is these are my favourite apps. And definitely point out the Google Authenticator app. If you haven't got two-factor authentication enabled on your Google account, definitely enable it. This is a cool little app that will give you that kind of random sort of digit and sort of really increase the security of your Google account. So this talk isn't about like fear. I'm not trying to like scare you into doing stuff or not. You know, specialist forensics people and hackers have been able to sort of get into mobile devices for years, you know, and not iOS, BlackBerry, Windows are kind of, no one's immune to this. But I'll show you some like reverse engineering techniques as well on Androids. They're actually quite easy to do. And it's also kind of not about making it 100% secure. Whether 100% security actually exists, I don't know. It's about making it incrementally harder and more difficult, so would-be attacker moves on to the next app. So it's kind of like similar in the way to kind of the way people put steering locks in their cars. You know, that kind of idea that a professional thief could easily get rid of that steering lock, but there's a car or 10 cars next to them that don't have it, so kind of move on to that. That's the kind of idea. So what we're going to cover, the kind of motivations for an attacker and some reverse engineering techniques on Android, and then sort of get down into the sort of some of the hardening techniques, Android permissions, encryption, using SSL in a better way. Some things you can do about making it more difficult to pirate or repackage your app, and then just sort of finish off with a load of device administration stuff. That's quite a cool little Android feature, and then finish up with some sort of just random kind of miscellaneous tips and things. So the kind of motivations to hack an app can be anything from, you know, extracting it and putting a different ad network in, and then sort of releasing it on another store to sort of make money from that. Extracting the assets and API keys. You know, you could even put malware and things like that into that and sort of release it to another store. Software piracy, so, you know, hacking, removing the need to pay for a game and things like that. Also, another reason, like the you know, security companies like Lookout, Symantec, they all hack apps to check for malware and to sort of validate that they're not malware. So, and fun. It's fairly easy to do. The next couple of slides, I'll go through it, and hopefully by the end of this, you'll be like, oh, I'm going to hack my own app, see what I can get out of it. So, you know, the reverse engineering this is the kind of cycle of for an Android app. So you kind of start off with Android code, fairly familiar for you guys, Java C that to classes. Then in Android, we sort of use a DX tool to sort of turn it into classes DX. But then from there, there are a couple of other kind of things like the APK packager and AAPT tool, which you kind of hidden from that in the kind of Eclipse environment. But from there, you can go using things like a Dexter jar and a back smiley to get back effectively to Java code. And you can that gets you back to sort of kind of compiled classes. And there's plenty of Java decompilers that have been around for years and quite robust, that you can just get back into straight to Java code. So that's the kind of cycle. If you're kind of just starting out in this and you want to have a quick go, APK tool is a really easy to use sort of APK reverser, and it's kind of combinations of a couple of different tools, assembler, dissemblers, and XML deserializers. This is an app that I wrote. I thought it would be fitting that I show you something rather than exposing other developers' kind of dodginess. So this is an extension for a dash clock, which is a kind of popular clock that Roman Urich, one of the Android sort of advocates, has released, and I sort of create a little plugin for that. And you can see this is the kind of APK file. So the APK file is just like a zip file, really. That's it completely unpackaged, and you can see my code. And then I just kind of quickly went to constants, and there you go. There's a secret key. So it's kind of that easy. So if you, yeah, it's kind of interesting to see. And that's the command you run. You literally install it, put it in your build path, APK tool, D, there your APK. That's it. You've got an extracted version. All the resources and images and stuff are out. So that's kind of one thing to look at. Santuku Linux is another kind of a thing which is good for all kinds of mobile apps. It's kind of like a Linux distro with a load of pre-installed SDKs and drivers and stuff. So you can load this up in a virtual machine and hack away to your heart's content. It's sponsored by a company called VIA Forensics, who unsurprisingly have a paid-for version called VIA Lab, and this kind of glues together all these tools and allows you to do a really quick health test. And disclaimer at the bottom, I work for these guys from Monday, so I'm not trying to sell it, but this is quite a cool tool. I've never actually used it, I've seen it in action, but the free version's really cool. But let's get on to the kind of hardening techniques. How can we kind of prevent some of our secret keys or things like that getting out into the open? So kind of one really kind of 101 sort of basic thing is when you're creating files, shared preferences, databases and things like that, you should always be creating them with context mode private. And that means that only your app in the sandbox can access that. So if you are using mode world readable and world writable, don't. And in fact, that's been deprecated as the latest version. If you are sharing kind of data between apps, you should look at using things like content providers, broadcast receivers, and services, which are kind of the Android built-in mechanisms for sharing things. But those components need also permissions as well. So when we think about permissions, we think about that kind of notification you get when you first install an app. This app needs to access your GPS, your network, your SMS. And in general, you should try and reduce the amount of permissions you need. This is just a quick example of how, if your app needs to send a SMS, how you can, instead of needing that very dangerous permission to send SMSs, you could just use an intent and just send it to the SMS app. I mean, that doesn't work if you absolutely have to send that. But if it's just a case of sending I don't know, I can't think of a good example, but that code does the same sort of thing. It just offloads it to the SMS app. So, like kind of the three kind of main permission types. There is a couple more, but for this purposes, you only need to worry about the three. Normal permissions are things like setting wallpaper, stuff you don't really care about and we're not really is going to worry the user. And dangerous permissions are things like access to GPS, network, and SMS. And signature permissions, and that's not something the user's ever like prompted for. It's kind of when you have multiple apps and you sign them with the same developer key, you have kind of inherited access to that, to the data and the kind of permissions that that app has. So this is just like a quick example of declaring a custom permission. So this is the kind of stuff you want to set on your services and your content providers and things that you're sharing between apps or you want to share with other apps. So just declaring a custom permission, and then this the example on the bottom is a component that I wrote that sort of declares that it needs to use that permission. So this basically just shows you kind of one component is declaring that it's got data, and the other one's declaring it's got permission to use it. The other kind of point around permissions is to not leak them. So kind of if you're in doubt, like when you're defining things like broadcast receivers and services and content providers, then there's a kind of flag in the manifest. You can set that as exported false, and it won't be sort of accessible to other apps. And in fact, lint, there's a lint tool that's part of the SDK now, and that's been flagging up those for a while, and it gives you a little yellow underline to say, hey, do you know this is exposed? And now I think it's becoming more and more. I think in the latest SDK as well, the content providers are by default exported to false. So Google have kind of like switched on to this and sort of changing it so default behavior is it's more closed off. The other thing you can do is to be a bit more fine-grained about stuff. So you can use those two snippets there, context, check calling permission and enforce calling permissions, to check that the person calling your app has those permissions. And it would be really great if the OEM supplied apps actually follow those rules. And I'm kind of looking at you, HTC, Samsung. A lot of the bad press around some of those things is because their supplied apps didn't sort of do this kind of thing. And if you're looking for, if you're just doing kind of sending intents and that messages between components within the app, they don't need to be, they need to go to other apps, then just use the local broadcast manager. It was a new class that came in, I want to say Android 4, but I can't 100% remember. But it's been backported, so you can use it all the way back to Android 2.1. So definitely worth checking that out. When it comes to sort of the data, you want to definitely want to look at encrypting that. There's a couple of libraries here that will really kind of help. I've used SQL Cipher for Android quite a few times. And it's very, very simple to use. You literally just change the import statements from Android database SQLite to a net SQL Cipher database, and that's pretty much the only changes you have to make. You have to just initialize it with a key or a password, which I'll kind of talk about in the next slide. But yeah, that's it. You've got an encrypted database. Quasar's something I found as doing research for this talk that looks really interesting. It looks interesting because it's got a lot of stuff defaulted to a strong security level. So if you don't know much about security and you don't really want to get into it, but you want it to be secure, then just have a look at that library. It's quite interesting. And IO Cipher is another one which is kind of like the sister of SQL Cipher, and it's basically, as I said, it's a clone of the Java IO libraries. But it kind of creates a virtual encrypted disk so you can read, write files and sort of be fairly safe that they're encrypted. So the Android SDK supports, sort of includes the Java cryptology extension, which is awesome. So there's loads of, you can do all the kind of strong encryption stuff that have been around in Java for ages. The tricky part is key management. And the kind of ideal world sort of solutions is, don't store the key on the device, and or use some kind of system service like a keychain, very much like iOS has. And although in Ice Cream Sandwich there was introduction of a keychain class, it's not really kind of suitable just to store like just arbitrary symmetric keys. It's more it's designed for certificates. One tip though when you're doing keys is to really, like, try and minimize the time in RAM so you can sort of null them after you've used them and things. One of the kind of ways to sort of generate keys is just, so you absolutely don't want to hard code it in the app. What you can do is generate a new key for every single app, every installation. And this is a snippet from the Google developers blog about how to sort of correctly do that. And in fact, there's a new version or a new implementation of secure random in the latest Android version to try and help with this, to try and improve the security, because some people were automatically or were overriding the seeds and meant you got the same kind of secure random number every time, which kind of defeats the object. So yeah, check that out. So the new changes mean you physically can't set the internal state of the secure random, and it uses the system entry for that. Although there has been some analysis of Android's entropy, and it's not massively high. But the best way is using password-based encryption. And there's a couple of different algorithms, but the one you want to sort of check out is that one. And then you kind of use the approach we just saw in the slide to create a random salt, and then you sort of use a fairly high iteration count to sort of cycle through. And what you're trying to do is trying to get something that takes more than about 100 milliseconds to create. I've got a code sample I'll show you next. But if you want to look at code on how to do this and what not to do, there's a great link to a GitHub library there, which has got loads of great examples in. So this is the kind of code example of that. So you take in the kind of pin code or passphrase from the user, the salt which you've generated on a per app basis. You go through, you define your output key length and your number of iterations, and just plug it in. Then at the end, you've got your secret key, and you use that in SQL Cipher or whatever to encrypt your data. Obviously, this kind of falls down if the password's really easy to guess, but it's just it's what you can do with what you've got. And obviously, kind of like password-based encryption isn't that suitable for like a long-running service, or maybe like a home screen widget where you need it to go on, be in the background and not be prompting the user for their PIN code every time it refreshes the widget data. And in those scenarios, I'm thinking of a scenario where you might want to know your number of texts and minutes left on your mobile account. It might be quite handy to have a widget with that information in, but you don't necessarily want that same login credentials cached. Those same credentials that could get you into your account and change details on your account. So you'd probably set up some kind of a separate key just for that, or just for that information. So that key, if it was compromised, could only ever get your balance, which isn't massively insecure. It doesn't get you into the account. So the kind of no-nos for encryption are, don't store the key in the app. That's just like locking your front door and leaving your keys under your mat. What's the point? It sounds stupid, but yeah, don't log stuff out with encryption keys. That's pointless having them. Don't rely on OS encryption. The device, although you can enforce it, there are ways around OS encryption. And don't write your own encryption algorithms. That's what that kind of pitches to try and emphasize. It's really difficult to write them, and you'll get it wrong. Use the standard ones that have been around for a while. Sort of moving on from encryption, let's talk about sort of SSL. Pretty much most apps will have back-end communication to a server, and by default, probably most of them, hopefully, are using HTTPS as a default. Problem is, it's not always implemented in a great way, and so that's where kind of man-in-the-middle attacks can come in. So I've seen code where people have, because on Android self-signed certificates aren't really supported, like out of the box, So if you kind of Google that or put it into Stack Overflow, you'll get a nice, highly rated post of how to implement it. And what it basically does is says, create a trust manager and trust everything. And when there's an exception, forget about it, don't worry about it. Which is great when you're developing, but when that code makes its way into live, it means anyone can just intercept those in the middle and be a man-in-the-middle attack and read all your nicely encrypted data. In fact, there was a study at the end of last year, and a couple of researchers used a tool called Malodroid to intercept comms, like apps like Twitter, Facebook, Yahoo, WordPress. They managed to get the credentials out of loads of these apps, these big apps that we've probably all got on our devices now. So it's quite interesting how many hadn't used that properly. And the other thing as well is the certificate authority could have been compromised. We had a couple of those in 2011, and so how can you sort of get around this or try and make it reduce that kind of trust in certificate authorities? So one thing you can do is pay attention to security exceptions. So if you've written code to accept self-signed certificates, handle security exceptions. They're a big deal. You can verify. There's a hostname verifier class that you can sort of implement to make sure that the hostname is what it's supposed to be. And one thing that's kind of sort of emerging now is SSL pinning. And kind of SSL pinning came around in Google Chrome 13. The idea is that you pin the kind of public key of the certificate authority that has that issued the certificate, because you don't need. Android ships with about 130 certificate authorities that it trusts. So if one of those is compromised, then suddenly your SSL certificate validation sort of goes out the window. But if you're effectively pinning to the one that, say, if my certificate was signed by VeriSign, I can pin to VeriSign, and so I only trust that one authority. So it just limits your exposure. There's a great library for doing this on GitHub. Definitely worth checking that out. And what it'll do, there's a Python script in that which will kind of grab the pin, which is kind of like the subject public key info from the certificate. And you can just dump that in your app, and you'll only trust those certificates. And in Android 4.2, they started to add this kind of facility in, but it's not really used. I think Google are a bit kind of concerned about breaking legacy apps, but when it is kind of used in more sort of appropriately, you want to extend that Trust Manager extension, and then you can sort of add your pins in there. So that should be quite. We're way off 4.2 being the most used OS, but when it does, that'll be the kind of thing you look at. The other kind of way to sort of avoid against this is to sort of not use certificate authorities at all. Is to sort of wipe the slate clean. So often when you develop an app, you actually control the servers as well, and so for that you could just create your own sign-in certificate. And this is kind of like an extreme version of pinning. You're just pinning to your own sign-in certificate. So you just, on the server side, you'd create your sign certificate. You'd sign the certificates for your web service, and then you'd include the sign certificate effectively in a key store in the app, and the app would then verify against those. So it's effectively similar to pinning, but you sort of take certificate authorities out of the equation. So kind of moving on from that, let's look at making it harder to pirate. These are kind of based on the Google verification library. So it's kind of slightly placed or biased. But the recommendations from Google, so you get this kind of code to sort of to add this license verification, which is all great. All comes under COM Android vending license. Yeah, that's all good. But that's the first thing that any kind of hacker or kind of someone trying to pirate your app is going to go for. So the recommendations from Google is to sort of edit that code as much as possible, add loads of random crap in there. And so they say focus on things like the license checker and the license validator. But really, the best kind of approach is to sort of offload that validation to a trusted server. So whether it's passing up some sort of installation ID or something like that, and validating it there, then you know at least that verification code hasn't been tampered with, or at least you have more of an idea. So talking kind of on that line about tamper resistance, you could build in something like a checksum in your app code to kind of validate against the server, or you might have a separate app which is the unlocker version. So it would validate that the fact that that app hasn't been tampered with. You could build in reflection-based tamper checks if you really want to make it a bit more difficult for would-be attackers to rip that code out. And one really simple thing would be to check the installer was the Play Store. Although that's kind of fairly a limited example because there are other app stores out there, but I'm sure they have different installer kind of constants there. So I mean that's just a really crude example of what you could do. Another kind of way to sort of add sort of tamper resistance is to obfuscate the code. So probably a lot of you have heard of ProGuard. It's been around for about 10 years. And if you haven't heard of obfuscation before, it's basically turning a class like that, Web Service Manager, into what it looks like there. So A's and B's, and just it sort of tries to mask what's there. And I'm not saying that security by obscurity should be your kind of only approach. Absolutely not. But it's just like making it more difficult. So it's really on Android. It's kind of been taken on board as the kind of de facto obfuscation tool. It's included in the SDK, and every new project you create will have a project properties file, and literally just on comment remove that hash, and that's it. You've got ProGuard enabled for your app. It's worth noting that you should. It's only applied when you're sort of exporting it using exporting it for build, not a developer build. So when you're sort of using a live certificate, so it doesn't go every time you kind of click build, and your entry points should be excluded. So that's an example of excluding your activity. All the exclusions, the default stuff is all built into kind of like a load of the default config file for your whole kind of workspace. So you often don't have to do a massive amount of config. It just works. That said, most of the libraries, the third-party libraries, are using things like Action Bar Sherlock, which probably most of you will have used if you've done an app back to use from 2.1 upwards. It has some explicit rules for that, so which is quite handy. And one of the cool things as well, it's quite well supported. So a couple of the Crashlytics tools, so things like bug sense and criticism, they're places where if the app crashes when it's out in the market, it'll send a log report up to the server. Traditionally, to get back from obfuscated code, to get a stack trace to make any sense, you have to run it through a tool to sort of reverse it using kind of mappings files and seed files. You can upload those files to like places like BugSense, and they'll automatically do that for you. So then you've got your error log and pretty graphs on how many errors you've got. But it does it all for you, so it's quite a nice way of doing that. One thing, if you're using ProGuard and you want to sort of make it even more secure, is there's kind of like a commercial alternative or commercial enhancement for Android called DexGuard. This is by the same dude, the same guy, Eric Lafortune, same guy that sort of did ProGuard. It's about £300 thereabouts per license, and it uses all the same configuration and stuff. It just has loads of extra stuff. It has things like you're not doing encrypt strings or explicit classes. I think the main point here is that ProGuard is a Java-based obfuscation tool, whereas this has been optimized for Android for Dex, and it has some cool things about like you can hide. It's built in so you can hide sensitive APIs, so it does that via reflection, which is quite handy. and it does that the check something I mentioned a couple of slides back. It does that for you, which is quite nice. And once you've got a license, you can do unlimited apps, so it seems quite worth it. I sort of did some testing on it, and when I used the APK tool to extract my app, I've got about 10 classes in there. So when I did that, when it was been pro-guarded, I got 10 classes still, 10 smiley files, with A, B, C, D. When I did it after it'd been dex guard, I had about 170 files with kind of weird kind of Unicode symbols, Chinese symbols, all kinds of messed up stuff. And I'm not like a skilled hacker or anything, so to me that initial thing was I have no idea what's in here. And trying to search through it to find my secret key was, I couldn't find it. So even just without turning any of those cool features on, it still managed to make it a lot more difficult to hack. It also has this cool thing built in to remove the Android login code. As we kind of talked about before, people sometimes log a lot of sensitive information they shouldn't, and it's just stuff getting left in there and forgetting to do things. This does it for you, but if you just want to do that, you don't need to. You can just use this. This is just some ProGuard config to basically blat out any kind of calls to the logger. At Moobly, we tended to use a sort of a wrapper for the logging classes, so you can turn it on and off depending on the debug, whether it's signed with the debug certificate. But this is kind of a lot more for sure. Like you're definitely wiping it all out. So on to the kind of next thing, which is device manager policies, and this isn't probably like a well-publicized kind of part of the API, part of the SDK, because you generally don't really see it on the public app store because it's kind of quite intrusive, effectively. But it's been available since Android 2.2, so Froyo, and you can enforce the kind of standard things that kind of mobile device management solutions can enforce. So things like device lock, password complexity, PIN code. From Android 3, we've had device encryption, so you can enforce that. You can enforce the use of a camera, and you can also do things like device wipe. There's like new policies. With each Android release, new policies get added. The cool thing, so you get different apps that enforce policies, but you can only make policies stronger. So if you had two apps that required the phone to have a PIN code, one of them was a 6-digit PIN, one of them was a 4-digit. The 6-digit one would win over, and you end up with a group of policies that are the strongest possible, which is quite good. I kind of like it because it's quite a small amount of code, really. I'll just go into that in a second. But it's a small amount of code for actually what you get. It really enhances device security. If you've got an app that is a business app, and it's kind of, I say, probably more geared towards BYOD type scenario, but you can enforce that users to have a PIN code. You can enforce them to have device encryption with very little effort. And it's also worth noting you can't uninstall an app whilst the device administrator, where it's still kind of active. And this is the screen you get when you install an app with a device administration kind of profile. And to set it up, you define a policy as an XML resource in your kind of resources directory. You reference it in the manifest. You create like a broadcast receiver to kind of receive those device administration broadcasts. And then you implement a device policy controller. And this is kind of really simplistic kind of implementation, but this is pretty much what it needs to be. What we're saying there is, is device policy active? If it's not, take you to that screen that we just saw in the last slide. If it's active, is the password that's been set sufficient? So this one's checking, is the password at a certain strength? If it's not, then take them to the settings screen to sort of do that. If that's all good, then go ahead and start a secure part of the app. I like it because it's quite a small amount of code, and what it gives you is quite good. but probably not suitable for a public app store. Certainly, I wouldn't install a game that wanted to use device management policies. But for maybe some corporate email or a sales presentation app or something where I knew it was very corporate data, then it makes sense. And sort of now I'll go on to sort of just the random kind of brain dump of tips. Validation. So this is kind of something we've been doing on the web for like forever. But a lot of apps use SQL-like databases, so you're still very vulnerable to SQL injection attacks and things like that if you don't validate the data. So definitely recommend using things like content providers, because you use something called content values, which separates them all out, as well as prepared statements, so you can sort of nullify potential SQL injection attacks. Other kind of anti-tamper stuff you can do, you can detect if the device is rooted. You can detect in a kind of fairly hacky way. I mean, there's no like Android dot is rooted or anything like that. There's a couple of different techniques you can use to check for SU, to try. The most kind of useful one is to actually try and run something as root, and if it works, you're rooted. So in that scenario, you might want to bomb out of the app or something like that. Or you could be more subtle about it. If you've got a game, why not just reset the high scores or something like that, or make the gravity go weird or something kind of game. Those are the kind of things which kind of wouldn't necessarily, like someone just cracking the app for the sake of it, might not notice, but then people using the app would, and it kind of would lead them not to use it, and either look for another pirated version or go and download the real thing. You can detect, in a similar way, you can detect if you're running on the emulator. You can check, there's a kind of build file with a fingerprint. So there's a load of statics which you can check out, and you can sort of check if they equal SDK or Google SDK, and do a similar thing. You can also check if debuggable is turned on as well. So you might want to sort of do some funky stuff if you realise the app's being debugged. So they're just things you can do. The other kind of things to think about is kind of cross-site scripting. So web views could potentially be dangerous. Disabled JavaScript if you don't need it. Use HTTPS if you can. Validate the URL. So if you've got web views, I typically use web views when things like terms of service and stuff like that. I'm a native apps developer, so rarely kind of use web views in a great sense. But they're useful things like terms of service, stuff that's going to change. You don't want to redeploy the app just because the privacy policy's changed. But it's effectively a window into the app, and you want to validate those URLs and make sure there's a certain subset that you accept. And there's some really cool features where you can directly from the JavaScript call Java methods. Really awesome, and that's how a lot of the phone gap stuff works. But that's potentially a massive hole in your app if this web view that's hosted on the web can now call directly into your app. It's potentially massive. So really restrict what the JavaScript interface can do. And in fact, there's been some new features in the latest version of Android which only really restrict that down, and you have to annotate every method that you want to call from JavaScript, which is quite a nice sort of default behavior. Avoiding unsecure components is another kind of tip as well. I mean, the SMS isn't secure on the network as well as on the device. You can easily call the SMS content provider. It's a hidden API, but it's very easy to do and just get all the SMSs. So if you had some kind of request user account SMS message, which then sent your username and password back, that's there that you could easily get to. So I'd definitely avoid doing that. Use a web service or some other kind of means. At least split the username and password up between different modes of transport. Don't use the SD card. It's a bit of a cop out, but to say don't don't use SD card, because sometimes you need more storage, certainly for those older devices. But really think of the SD card as public readable, public writable, because that's what it is. So you can't really trust anything that you've stored there as sort of staying without being tampered with. Avoid sensitive data in public intents, because they can be interrogated and you can get stuff out of that. Same with like sticky broadcasts. With normal broadcast receivers, you can add permissions and things like that. With sticky broadcasts, you can't. So that's one thing to sort of be aware of. And also, there's this cool feature of Android where you can back up, which allows you to back up the apps and all the data in it. And it's just a permission you set on the kind of root application element, and you get an annoying warning from lint when you haven't set it. But you should set it to false, because the security of that kind of cloud storage for your app and your data isn't guaranteed, and that's kind of a recommendation from Google, is to sort of not use it if it's kind of a weird thing. Don't use it if security is important to you, like as if it wouldn't be. And the other thing is, it's more of a privacy thing, but don't use the phone number or the IEM number or even device ID as kind of as a kind of unique identifier for users. Generate a large unique number on app installation. There's a great article on the developers blog from, I think, 2011, which talks about how to do that. And yeah, that's more as a privacy thing, so people aren't tracked between apps. And the kind of sort of the last couple of tips is really think about your development process. I mean, I think this still applies for one-man developer to like teams of developers, I think. Think about how your code is, the access to your code, and are your key stores and passwords stored in the same system as your code? Is the credentials for the App Store also in that system? So then if someone's compromised that system, then suddenly they've got access to completely upload a dodgy copy of your app. So things you can do on the App Store is that enable the two-step authentication, like I mentioned earlier. And also, they've got this new feature on the App Store where you can grant access to other Google accounts to publish apps. Certainly at Moobly, we do apps for other people. So the amount of times people have tried to give us their username and password, I'm like, no, just add our email address and we'll do it. And we don't need to know those kind of details. So that's a much safer way of doing it. And then you can then disable those accounts, afterwards, and you don't have multiple copies of that, account details lurking around the place. So I guess what I'm saying there is don't have all this information in the same system. The other thing worth noting with kind of key store, so the key store is what you use to sign the app to say this is an app that I've developed, and once it's signed, apps can only be updated if they're signed with the same key. Problem is, keys can't be revoked. So if you ever lose your key or it's stolen, you can't say I'll revoke that, I'll create a new one. If you did that, the users would have to install a new app. You couldn't upgrade. Also, there's no way of Google or anyone to sort of, if you lose your password or your key, to sort of magic that out of nowhere. So you have to keep it safe, but also keep backups of that and keep those safe as well. And really, from a development point of view, it's kind of it's the process as well. It's part of educating developers. Really paying attention to those lint warnings. That's the lint tool's great for flagging those up and really make that part of your build process. There's a really useful tool for Jenkins if you do continuous integration, which will give you a nice graph of your lint warnings as the project progresses. That can be quite good to sort of try and keep that low. And if there's one particular developer that's always kind of things seem to spike when they put stuff in, you can try and target that. And the other thing is, do audits, do security code reviews, because that's the stuff. All the kind of stuff we just mentioned is stuff to stop it from being those kind of trust all things being left in the code. So hopefully I've kind of, that's a link to the slides if you want them off speaker deck. Hopefully I've kind of pipped your interest to try and use something like APK tool or one of the other tools to kind of hack your own apps and see what you can get out of them. Because it's quite eye-opening to see for yourself, and when you realise how little work you've had to do that, you can see why there's loads of automated tools that will repackage, will download your app, repackage it, and upload it to another app store. And actually, one thing I didn't mention for the DexGuard stuff, it does break a lot of the one-click tools. So although I was able to get the APK tool to extract the classes, it failed miserably when it tried to get any of the resources and drawables out. So it's kind of just, again, making attackers move on to the next app sort of thing. And so use HTTPS for sure, but make sure it's going to validated connection. So things like pinning your certificates is a good way of doing that. Encrypt your app data. Don't rely on the fact that the device can be encrypted. And then I showed you a couple of really cool libraries to make that, really easy. Pro-guard the app, obfuscate the code, make it that more difficult. And the other thing is, Android is getting more secure. If you look at some of the features, if you download the slides, you'll find some bonus slides at the end about Android 4.2 and 4.1, about some of the cool security features that have come into those platforms. We're not kind of there yet with with the platform distribution. Gingerbread just won't die, but new phones are still released with Gingerbread. Why? I don't understand. But yeah, so it's getting more secure. So it is getting better. So they're kind of my top tips for hardening your app. Thank you very much. Cool. If anyone's got any questions, just shout. Okay, so the question was in the slide where I talked about password-based key derivation. I can never say that word properly. The operation should be more than 100 milliseconds. That's because when you're brute forcing it, you want to make it as long as possible. So you do all those kind of things and the iterations to make it. You use that to derive the key, and the key is what you use for the encryption. So the longer that takes, it's kind of a trade-off because you don't want it to take a crazy amount of time. But 100 milliseconds is about what Google recommend for it to take. Then it makes brute forcing a lot more difficult. No, nothing like that. No. Yeah, go for it. Yeah. Yeah, no. So the question is, effectively, if I paraphrase, what's the point in checking for root? If they're root, they can block or mask and do anything they want. You're absolutely right. They're like I kind of caveated them saying they're hacky techniques. You check for the example of the existence of the SU app. You try and run something that you're not meant to be able to run. But yeah, they're kind of hacky. There's no surefire way of doing it, and there probably can never be, because if the device is kind of rooted, then you can make it do what it wants. So. Oh, sorry. So the question was, should you restrict your app from running on rooted devices, because fair few people have rooted devices? Okay. Well, it depends. Once the device is rooted, you kind of circumvent all those great security things that are built into the platform. So I don't know. It's a good question. I mean, people like Barclays and WorldPay and things like that, they stop their app from working because you can't restrict it. So it depends what the security is worth to you. It depends on the app. I personally would, but I can appreciate where you're coming from. If you've got a rooted device, it's a bit annoying to get that little warning to say, hey, this device has been rooted, this app won't run. But your app data is more prone to be compromised if it's on a rooted device. That's kind of a fact. So. Yeah, so yeah, it's if you're rooted, then all the kind of the inter-process communication, security, and that doesn't, you can get around that. It doesn't. The app sandbox is suddenly kind of exposed. Not just straight away, but you can circumvent it a lot easier. So yeah, I think it's more if you've got a rooted device and you download a dodgy app, it has more freedom to do what it wants. Read your preference, say share preferences where keys and stuff might be stored. And the recommendation from Google, I saw a slide where we generated a key based on the app, and they say store it in a shared preference with context mode private, and then it's protected in your app sandbox. Well, if it's rooted, you can make yourself root and get into that, and it kind of defeats the object. So that's the kind of idea behind saying, if I'm on a rooted device, I can't guarantee security. So don't run, or like I said, reset the highest scores or something annoying like that. Cool. Yeah, go for it. Good question. I don't know. I just saw a study, a report, which was saying comparing Android, the way it generates secure random numbers is lower than, say, like Java, straight out of the box. And that's what the study was saying. So I just thought I'd mention it. I don't know the details of why that is. Yeah, go for it.
So in a run your own device type scenario, are there any strategies that you're to limit or authenticate the devices that are running your app?
So the question is, in a bring your own device scenario, can you limit the devices that are running your app? So like, you want to say, hey, device 1, 2, 3, device with ID 1, ID 2, ID 3, only they can run the app. Good question. I mean, that's the kind of thing you could build into the app. I mean, you could pass back things like device ID and stuff like that. If you want to get that, it's probably more, you'd want to do it on the user level, wouldn't you? It depends if they were kind of public devices that you were handing out to multiple staff members, maybe. Yeah, device ID. You'd probably want to do it on installation ID. So create an installation ID when the app's first created, register that on the server, then it only works for those. So if that installation ID is compromised, or that app is compromised, you could deactivate their access or something like that. Okay. Cool. I've got time.